I'm doing foolish things apparently. Damn it! How does it work? I just want to use package config from the command line. What path does it need? So where did my find here? It exists in this path here. Package config. Do I need a lib? Finally we have it. This is it had to be exported. Was one of the first things I tried, but I had not exported it. I don't know why. That didn't work, but okay. Now let's compile it. Right, also have to link with CWDS. Maybe just linking with this will do. So now I have a libcwd debug support output. No, I sleep. I just sleep 8 hours and the rest of the time I'm working. Notice entering, so that would be 16:24. Well, that's not true. I think I only work 8 hours a day, 10 maybe, 12 sometimes, it depends. Entering main. So now I can finally edit this and replace all my debug output written to standard cout. No, it's a test program. It's a test program to test letting n threads try to acquire a subset of resources from a pool of resources. I'm now replacing all the standard couts with debug output from libcwd. Which is some dumb work. It takes a while, but well, eventually I'll have them all replaced. Step thread. Let me just print the ID for everything between square brackets. No, let's keep the comma, why not? Okay, nice sword. AA Gaia sword. I've been programmed since I was 12, so that is 46 years. 28 years in C++. So now I can compile it again. What did just happen? I can just run out of ADOL out. Okay. Now I want to run a shorter version, so I'm going to edit again using a random seed, and I'll run it until we run into the assertion very quickly. In order to see how quickly that is, I guess I have to print resetting everything. That's only one, so that would be good, but now I don't have my seed. Arrgh. Okay, so with this seed I need to wait 5 times. That's not interesting. That looks very interesting. It happens even before the resetting everything. Really? So let's try this seed. Compile again. Well, there is a resetting everything here at the top, but yeah, that's kind of unavoidable, I think. So this is, I think it just got swapped here because this is standard out and this is standard error, I guess. Okay. Yes, I'm, well, I wrote a test program yesterday of 200 lines. And now I'm looking at the output of the test program. The question is why this is wrong. And I'm afraid I'll have to go over all the output now. Reset everything, resources. We have 8 resources that are all like that. These are the threads that we have, which have M running is true for all cases. And we have then number of running thread is 4, running thread 2, which succeeds M owner now contains the 2. That's this thread 2 here. Running thread 1 succeeds owner is now 1. Running thread 0 succeeds M owner is now 0. Running thread 0 again succeeds also owner is 0 now. Running thread 1 succeeds 1. Running thread 2 succeeds. So now that's quite a coincidence. exactly gets all the resources, it seems. And oh no, 0 for resource 0. No, resource 2. Yeah, the coincidence here is that it gets 7, 3, 1, 4, 6, 5, 2, which is all of them except 0. And then finally it tries to get a resource that it already got. Again, 3. Entering, so now thread 2 is trying to acquire resource 3, which was already gotten by thread 1. So it says failing because thread 1 already acquired the resource. Owner now contains 1, 2. So 1 is the first one that got it and 2 is now waiting. Setting running to false, after which entering print threads. And this thread is not running, which is thread 2. That's correct. Running thread 3, entering step 2. What is passed here? 2 is 2 is the running index, I think. So that seems correct. That would be this 2 here. Let me see. Okay, thread 3 is trying to acquire a resource 3. No. This 3 here is something else. This is the resource, right? So it's trying to get 4. Failing because 0 already acquired the resource. Let's just print it out. I find it a little bit confusing, especially at acquire, because it mentions 2 things, or the step as well. So this is the, yeah. Let's improve the debug output. Well, since all the resources are printed as well here, well, now I'm printing all those threads, you can see that this is true. Failing because thread 0 already acquired resource 4. So these are the resources, and here's a resource number 4, and you see that the owner is thread 0. So that's correct. And after that mowner contains 03 because the 3 thread is appended to it. So this is now changed to 0,3, what you can see here. Now ID is owned by 0 and 3 is waiting for it. Also, thread 3 should no longer be running. And that's true, running is false. So the only running threads now are 0 and 1. And then we continue with running 0. Entering step RI0. Nobody knows what this is. This is a thread. Thread 0 is running. Entering resources acquire thread 0. Resource 0. Thread 0 is trying to acquire resource 0. Success. Oh yeah, we had all the resources except 0 acquired. So now we have all the resources acquired. Owner of resource 0 now contains thread 0, setting MR to 4, so it has a lot of resources. And we run thread 0 again, entering resources acquire thread 0 resource 6. Failing because thread 1 already acquired resource 6. Can we see that up here? Yes, it's true. 6 has been acquired by 1. And therefore the thread 0 is being appended to this list. So down here you see that it changed to MID 6 now contains 1,0. Setting M running to true. After which, this is very confusing because it says failing. And then it says running to true. Well, obviously it should have been setting running to false, what it does here. So it is doing something in between. But what? So I'm going to select this and see where this is printed. Just simply print it in thread run again. So I should add debug output here, dout entering DC notice thread run again. We print the ID as well. I kept being confused. I mean, you can see that the whatever is between square brackets is the ID of whatever class is being printed. This is the scope here. For us, the class here. Well, it should be clear enough, right? I think was also printing the number of running threads, maybe, wasn't it? Yeah. Or I is larger than 0. Why? That's bullshit. I think this is the bug. This must of course be larger or equal than 0. Hi Retin, let me read your comment. I think you meant the only comment that I saw, but I don't know. I mean, at some point chat is turned off. But someone asked, do you really think someone will fix your code? Was that a question? In that case, I did read it, but there were no other comments when I got back here. So either that was it, or your comment didn't make it. Because the chat was turned off, because the stream had been ended. To answer that question, no, I did not really think anyone would fix it. So you already have 29 viewers. In case there are a lot of viewers that were here at the last stream, I did solve the problem while I was laying in bed. And I'll explain in a minute what my solution is. But I wanted to fix this test program anyway, so I can also test my solution, I guess, with this program. Well, it's still crashing. The threads are actually tasks, and the tasks are pipeline factories. And the resources that they try to acquire are the shader resources, like uniform buffers and detectors and stuff. And I try to acquire them because then the pipeline factory is going to create those resources. And of course I can only have one thread take the responsibility of creating something. I only want any resources to be created a single time. Let me read that. I read in Akil said the algorithm has certain issues. First of all, line 207 run again method cannot brute force all elements since you're using number of running threads. I just fixed a bug in that. Okay, let me first read the rest. Line 108, if you call reset and method step before the swap operation, you'll end up asserting because reset calls run again. That one might be a remaining bug. It might end up trying to run an already running thread. Lastly, when I tried to fix them, I ended up deadlocked. Maybe it will help. Well, if you can tell me how you fix it, because the deadlock is still going to happen. I just don't want any asserts anymore. Let me show what I just did, instead of then looking at my debug output. So your first issue is that I started running number of threads, but I think that is correct because suppose we have two running threads. Let's say 3 is running and 2 is running. No, let's not make them adjacent. 1 is running, 2 is not running, and 0 is not running, right? So I have an array of size 4 and it contains 3, 1, 2, 0 in that order. And we have number of running threads equals 2. And now let's say that thread number 0 must be run again. Then what I want to end up with is, after my swap, that 0 is now running, like that. So the number of running threads must change from 2 to 3. And what I'm doing here is I start with the number of running threads before I increment it. So number of running threads is still 2 here. And then I swap that with the index of whatever this thread is at, which means that I'm swapping, so index 0, index 1, index 2. So I swap my 0 with index 2. Okay, so this one is put there. And then the number of running thread is incremented by 1, and then you end up with this. But it said here while our I is larger than 0, which meant that I would not find it if the current ID would be... Oh, well, actually that does not make any difference. Yeah, okay, so yeah, so it did not fix anything. I would say this is the running index starting at the end, where are the not running threads are at the end, so I start at the end. I would miss 0, but 0 is here, and that's always running. If there are no running threads, then we don't call this because they're already deadlocked. But you have another comment. So second of all, if you call reset in method step before the swap operation, I'm going to delete it again. If you call reset in method step before the swap operation, you'll end up asserting because reset calls run again. Yeah, you're right. Well, I won't assert because run again is going to increment the number of running threads. But it's not correct to swap with a number of running threads at this point. Or maybe it is actually. But there's definitely something, some problematic thing going on here. Can we reset at this point? I'm not sure yet. Let me see. Yeah, let's try to put the reset below this print threads. Doesn't the reset print that it is being called? That's irritating, not working. You say, but there must not be a running thread in the array which has index higher than any stop thread. Yes, that's true. But I'm using indirection array. So not entirely, it's not super trivial. No, I forgot again something. And still we're going wrong. Well, I don't know, man. I'm going to look at the output, which completely changed, I must say. It's a second time. And a third time. Yeah, I still want to, I don't know, feel safer to use a seed where this happens immediately. Which would be this seed. Reset. Okay, let's see if we can go faster through this now. The beginning just works, right? I mean, it says success, success, success. Then this one is already failing because it's trying to acquire resource 5, which it just already got. Failing because thread 3 is already have it, and then setting am running to false, number running threads now 3, after which thread number 2 is no longer running. It's correct. I think it would be slightly more insightful if I also print in the indirection array. So let me print after print threads also that array. Which is called running index to ID. Yep. Print threads. So we print the threads, and I'm also going to print indirection array. What? T was not declared. I've got one or I. Okay, I think we started at the top, a few successes, and then we get a failing, and now we have these threads. We have thread 2, which was the one that failed, is no longer running. And here I can see the indirection array. You see that thread 2 is at the end. Right, so 0, 1 and 3 are running and 2 is not running. Apparently thread reset is not doing anything. Running thread 1, entering step redirection, running index is 1, so that is this one, and corresponding thread number is still 1. Entering resources acquire by thread 1, resource number 1. Success, because resource number 1 was not acquired yet. As we could, for example, see here, there's no owner for 1. Owner now contains 1, setting mr to 1, running thread 1 again. This time we tried to acquire 4, which was not acquired yet, so now the owner of 4 is 1, and then we set mr to 2, and another success. Resource 7 was also not acquired yet. Running thread 3, entering step, entering acquire resource 7. Well, 7 was just acquired by thread 1, so it says failing because thread 1 already acquired resource 7. Owner now contains 1, 3, because this is thread 3 that try to get it. Setting m running to false of thread 3. Number of running threads is now 2, after which so now only 0 and 1 are running, and number of running threads is 2, so these are the running threads, and 3 and 2 are not running. Coincidentally, they are also at the end of, because, well, 2 and 3 are the two largest numbers. They're also at the end here, so yeah, not running here and not running here. That looks completely correct to me. However, we call reset. Why? Because this thread that failed is giving up now. So if it was owning anything, it's going to release that, and it is owning a lot. Oh. Wait. Okay, what's happening? Okay, it's trying to acquire 7. That fails because 1 already has it. So it's now waiting for thread 1 to release resource 7. That means it can release ID 5. Okay, I was seeing 2 of them, but there's also this one as well. But it's just resource 5 was owned by 3. It's going to release that, and I think that is the only thing it was owning. So we call reset. And that calls run again on 2, because after removing the 3, now 2 is running again. 2 was waiting for this. Number of running threads is now 3. Setting m running to true, after which, and now 2 should be running again. Yep, and that's wrong, because 2 is at the end. Let's see if it It did it correct here, it seems. Thread ID 2 is now running. And so are 0 and 1. And 3 is still not running. But the running threads must be at the beginning. So these two should be swapped. That's incorrect. And then eventually it goes wrong as a result of that. So this is inside run again. I think there might be a problem with incrementing number of threads before. If this was still 2, we would have swapped with the second index. Because the number of running threads, yeah, I think we have to swap with number of running threads -1 or something like that. No, that's not what I wanted. No, it's printing it here. Let's print threads also up here. And then we swap. And then we print it again. And something goes wrong in between. In this function. Okay, so what we have is this, and then I want to start thread 2 again. In order to do that, I have to swap index 3 with index 2, where the 2 is equal to the number of running threads. But it's not swapping anything. Okay, I'm probably being stupid again, but let me just print out also what it is swapping. Oh, what? Why does it start here? Is this what you meant? I read an Akil. I think this is what you meant, because yeah, only now I see it. The intention was that I would just start at the very end of the array. At times I'm so stupid. It's amazing. Oh yes, I know. I totally overlooked this. I did not. Yes. Sorry, man. I am. Risk. Yeah. Well. I could do that if there's any interest in between the viewers. Number of running threads. Probably not today though, or at least not this stream. I don't know. Number of running threads should be just the number of threads. And then the 0 is kind of nonsensical. I mean, it's going to find it. It should always find it. I can make it like this, or maybe even add an assert so I know that it found it. So it loops until Ri becomes 0, and if that is the case, then we assert. Because what it should do is when Ri is still 0, it should find it and then break, and then we are still larger than 0 here as well. Great. So I still want to see what happens now. Is that let's say the first one is this is the start, and then the first red arrow is here. So now it says looking for ID 2, and it starts at 4. No! That's where you have to start. Well, it's not asserting anymore, but it's running forever or something. I think it's time to run this without debug output, see what then happens. I think there's an easy way to turn off the debug output. DC notice off. Or you meant it never stopped, not that it deadlocked. I mean that it printed deadlock. Yeah, pretty clear. Okay, and what about for other seeds? Do we absolutely never end? I mean, sometimes it must succeed. Angelo, yeah, well, you will be surprised. This is just a test, an algorithm that I needed. Well, okay, it never ends, whatever. Is it? Okay, like I said in the beginning, I think I already solved it. And let me try to implement my solution now. Flooding is not okay. I respect that you're only a little kid of 11 years old, but no flooding, man. Okay, I'll be nice and explain what my solution is according to me before I try to implement it. But I wrote something in the README, didn't I? So here's the image of what I had. So we have 4 threads in this case, and we have 1, 2, 3, 4, 5, 6, 7 resources, A, B, C, D, E, F, and G. And each thread wants a subset of those resources. This one wants 3, this one wants 5, this one wants 4. And the question was how can I implement an algorithm so that without wasting a lot of CPU we can decide which thread will create which resource, which then starts with electing a single thread that will get a go at it first. In this case, if any thread gets a go at creating its resources, then none of the other threads can run, because every resource is being created by at least 2 threads. So let's say if T2 is the one that is being elected, then it is going to create B, which means that T0 has to wait. It's going to create C, which means that T1 has to wait, and it's going to create E, which means that T3 is going to wait. My solution is as follows. Consider this a horse race with 7 finishes. So the horses start running, little horses here, 4 horses, they start running. When they reach the finish A, the first finish, only 1 horse can be first. The others lose already, immediately. So let's say that T2 is going to win. So the horses are here. Here's a horse. This one passes that finish first, and this one doesn't. So T1 is winning here, and T2 is here or here. It doesn't really matter because it isn't participating in this first race. That means that T1 did win the race of A, and that means that T3 and T0 just back off. So the only contenders now are T2 and T1. And they go on at their leisure. It doesn't really matter when this one passes B, because it's not a race with the one that's still running. But let's say T2 passes C first. So this horse is now here. This one is waiting because it's not allowed to pass H. And this one is too late to pass C. So the C finish is won by T2, blocking T1. And now this horse is the only one that is running. And it's going to pass D, E, and eventually G, and T2 is the one that gets to create its resources. That's my solution. And as you can see, very well doable while you lay in bed with your eyes closed. Now, how can I make this work, and why is the current test program not working? This only works when the goals are achieved in the same order. So I have to order them. At the current moment they are not ordered. So I'm going to sort those resource vectors of each thread, and my prediction would be that then it should work. So we go to init. Where's my init call? Yeah, thread init. So somewhere down here. Here's thread init. So we do a pushback here of the resources, but really I need them to be sorted. So let's add a sort here. Which is going to require less than functor for the elements of this thing, which is resources. No, ctext is not working at the moment. Resources are pointers. That will do. I mean, as long as they are unique and the same for every thread, and the resource pointers are unique, I think. for any given run. Yeah. Let's see if this works. Damn it. How is that possible? Okay. I guess there's only one way to know, and that is turning on the debug output again. Have a look at what the hell is this doing. Let me use something reproducible. So just take the same seed as before. Okay, maybe you can do this, maybe you can reproduce this with less resources and less threads, and try that as well. Just try to reproduce this infinite loop with as little resources and threads as possible, which would be ridiculous low amount of 2 resources and 2 threads. I mean, with 1 thread it's always going to work. Right. Not even sure if the program works with that few. No, not that one. That one. Whoa, whoa. It is hanging with 2 resources. Gotta be kidding me. Pretty ridiculous. Well, at least that makes the debugging a lot easier, I guess. Entering print resources. We have 2 resources, no owners. We have 2 threads. Both are running. Both want to get both resources. Should still work, I think. The scammer that just wants your money. It's back with its bots. Number of running threads is 2. Running thread 0. Entering step. Entering resource acquire. Success. Owner now contains 0. Running thread 1. Failing because thread 0 already acquired resource 0. Owner now contains 0,1. Setting running to false. Number of running threads is now 1. After which thread 0 is still running, thread 1 is no longer running. Looks correct. Entering reset is not doing anything. Running thread 0. Okay. It prints success and it continues. Oh my god, oh my god. Everybody leave. I'm just too stupid to watch. Obviously. What an idiot. But I should have printed that. Did I remove printing that? Okay, at least now we know what is going on. It works like a charm. It's never deadlocking, it's just that the number of steps is always less than 500. The only thing that I would have expected is that at the moment of success, steps should be larger than max steps. And therefore we should get this output here. At least once. So what the hell is max steps? Max steps is 0. So yes, if success is returned, no. This success here. It prints success and then doesn't do anything different. No, that's something else. Wait a minute. I have to look at where the MR is incremented. Returning success. It is printing it. Thread 0 did get a lock on all its resources after 2 steps. Okay, I'm a complete idiot again. Sorry guys, I'm really stupid. I have no idea why I just don't realize this until I see it spelled out by the debug output. Right, now it should work. Might as well turn the debug output off again. So it is succeeding in 3 steps all the time. That's success, and I'm going to increase the number of resources again to 8 and the number of threads to 4. Apparently that succeeds always in 47 steps. "49 steps, it just took a while." Okay. "53 steps. We have a lottery win. We did win the lottery." Yeah, Vidya Vic, yes, I can explain. The problem was this. We have a certain number of resources, A to G, and 4 threads, or a number of threads. And each thread wants to get a hold of a subset of the resources. And there's only wants 3 of them, and there's one wants 5 of them, etc. And then I made an I'm not into cheating. I needed an algorithm that would in a few number of steps, so without wasting CPU resources. Elect which thread gets first. So let's say this one is allowed to create A, C, D, E, and F. They have to be created, those resources. And then the other ones are not creating that. Now I have this algorithm. Yeah, repeating is flooding. Even though you type it again, I'm gonna kick you out if you type it again. Good. Now I have to implement it in the real code. And in order to do that, I need to remember where that was. That was in... which function was it? Isn't it like called from? I'm programming a Vulkan engine. Okay, this was the crucial function where the race has to be solved. The threads are the threads that are calling this. And the resources are the resources in this list. Realityscape, this project around 2 years, I think. I'm heavily using code that I wrote in the past 20 years though, past 10 years, but the bulk of the code is, code that's 20 years old is almost not usable anymore because of the changes in the C++ itself. You have to keep working on it, but you know, some of the code has its roots from a long time ago. So I need this to be ordered for each thread. Let's start with that ordering, because that was part of the algorithm. I can do the same trick, I guess. I can just order on the pointer here. That should work. So the shader input data object is a member now of the factory, the pipeline factory task, and tasks are inherently single-threaded. That's a really nice thing of those tasks. You don't have to worry about mutexes and stuff. So a certain task is entering this function. And this task owns its own members, as is if it is single-threaded. So I can just simply, or this one, yeah, it's the same. I can just sort it. Nobody else, no other thread is going to access that thing because it's owned by this task. Right, it's owned by the task that owns this object. Right. Then we need to try to acquire them one by one. I don't think I have this anymore. I just have a single loop. And I'm going to try to acquire them, just like in the test application. Cannot pass this pointer. I need to pass the pipeline factory pointer. Which I don't think this object has. Maybe you can pass it as an argument to this function. It's called acquire by and then the task. So the task tries to acquire the resource. My keyboard keeps dropping off its hinges, or whatever I could call it. What to do here? Yeah, I need to get the task. So let's save this. Grab project sources for that function. See what we call it. That's being called there from a pipeline factory. So we're definitely going to have the pipeline factory pointer. I'm passing an owning window. I guess also necessary. So this pointer is really a task, pipeline factory. Scroll up. This pointer is a pipeline factory pointer, not even const. And I need to change therefore the declaration of this function. Yeah, let's call it pipeline factory instead of task. And I have the feeling that we do not know what that is. So, but more than a for declaration does not seem necessary. So I'm just kind of adding it here. Pipeline factory. Which is defined inside task. Okay, now there's the possibility that this acquirer is going to tell me that it lost the race of this finish, and it means that we have to give up. And I think that was this bool. Returns true if this task thread succeeded in creating all shader resources, and false if another task is doing that. So if it loses even one race, then we simply return false, because we lost. And otherwise it's going to return true in the end. Well, that is if the acquirer failed. Oh, great, Steve. What language is your main language right now? Also C++? Jeremy. Right. So I'm at 28 years of C++ now. But well, the C++ is changing so fast that a lot of necessary knowledge about C++ 11 and on 17, 20 is unnecessarily recent, of course. My memory is clearly degrading. It's not the case that I have 28 years of experience in C++ 20. As you will understand, not even C++ 11. But I guess it's the way of thinking, the way of object-oriented thinking that is that I have a lot of experience in. Well, it's not lunchtime, Jeremy. It's almost your bedtime. Okay, if you take me for example, I don't even have lunch in the house. I should be shopping, but I'm not. So I skip my breakfast. I'm probably going to skip lunch, and then some visitor comes here. So I don't have time anymore to go shopping. So what any sensible normal a normal person would do is stop the stream, take a shower, because I haven't shaved in a few days, and go shopping food and then eat lunch before the visitor comes. But it would mean I have to stop coding. Oh, what? Oh yeah, Steve said that he lives in New Zealand. Let's see. Seems easy enough now. However, I'm going to use something horribly complex that nobody will understand very soon. Namely a task mutex. I'm not so sure anymore that the create access type is correct. We need to do something with it. We need to call acquire by. Doesn't even exist. So it means that I have to first right lock the thing. Yeah, probably should right lock it if I want to add a. I want to add something to a FIFO, right? To a DQ. I think the create access type now can do with a simple right lock. And let's change this thing into something that uses a primitive. Simple mutex. On the other hand, maybe I should use the task mutex right there. Yeah, kind of makes sense. Although I would have absolutely no idea how that works. It's a while ago that I used it. And this thing needs to not have one owner but several owners. DQ of base pointers. Definitely not const anymore. So this one has a boolean called acquire by. Task pipeline factory, although I don't think it really matters anymore that it is a pipeline factory. Let me just pass the base class of that thing. So this is going to be a stateful task pointer. Doesn't exist. Let's see if we can do that here. So this thing is already wrapped together with the mutex now, and the mutex will be locked when this is called. So we can just simply try to add it, and this is again the same as the algorithm. So first is m owner is empty. Success means we were first. And in all cases I just want to do a pushback of that's a base pointer. What is this? Yeah, okay, that's nonsensical. Nonsensical. Maybe I should go take a shower and shop food, because I'm starting to lose it again. It seems. acquire by acquire by stateful task pointer task. If we are the first, then we succeed. If we are the first for everything, we've completely got it. In all cases, it's being pushed back. Yeah, let's compare this now with I hate it. So this is my working test application for the algorithm. And where was it complaining? In C tags. Oh, blip. Well, then where is that added? Oh, here. Yeah, and that's equivalent apart from the debug output. So if acquire fails, we must stop running. And call reset. Where reset runs over all the resources and calls release on every resource. How does it translate to this code? We return false. Yeah, I think I have to do that. I cannot stand sound. I'm hearing through my own microphone some machine outside. Why are people making noises? Jesus Christ, even the floor is... my whole house is vibrating. I think this is the moment that I stop the stream. I'm going to do some shopping so I can leave my house. No idea what they're doing, but I cannot stand this.